channel. Vanakkam. In the previous video we have discussed about Arrhenius acid-base concept. Arrhenius acid-base concept has some limitations. It does not explain the basic nature of ammonia because it does not contain OH group. So Lowry Bronsted concept is introduced, which explains the basic nature of ammonia. What is that Lowry Bronsted concept? According to this, an acid is a substance that has a tendency to donate a proton to another substances. Base is a substance that has a tendency to accept a proton. Acid donate a proton, and base is the substance that accept a proton from another substance. So simply say acid is a proton donor and base is a proton acceptor. And so Lowry Bronsted theory is also known as proton theory. Okay. Now consider the hydrochloric acid. Hydrochloric acid in water dissociate to give Cl minus and H3O plus. Here HCl donates the proton to the water and water accepts a proton from HCl. So HCl is acid and water is a base. Clear? One more example. In case of ammonia, ammonia reacts with water to give NH4 plus ion, ammonium ion and OH minus. Here water donate a proton to ammonia, so it is acid. Ammonia accepts a proton from water, so it is a base. Okay, so it is in equilibrium condition. So in the reverse reaction is considered, what happened? The ammonium ion donates the proton to the OH, that is, it is an acid, it accepts a proton, so it is a base. Water is an amphoteric solvent because it behaves as acid and base. So we have discussed in this equation, what is that? Hydrochloric acid and water. Water behaves as a base. Ammonia and water behaves as acid. So water behaves both base and acid, and so it is an amphoteric solvent. Okay. Then conjugate acid base pairs. So what are conjugate acid base and pairs? In Lowry Bronsted representation, we have seen that acid 1, it loses proton, so it will become the base, corresponding base. The difference is nothing, only the proton. And base 2 and acid 2, the difference is only the proton. So the chemical species that differ only by a proton are called conjugate acid base pairs. So there is a only difference is proton. Lowry Bronsted concept also having some limitations. For example, boron trifluoride, aluminum chloride. Boron trifluoride and aluminum chlorides are in general, they are acids, but they do not donate a proton. So BF3 does not contain proton. So BF3 and aluminum Cl3 etc. like Lewis acid do not donate proton but behaves as acid. So this cannot be explained by Lowry Bronsted concept. Okay. So by Lowry Bronsted concept, acids are proton donor, bases are proton acceptor, water acts as a amphoteric solvent because it acts both acid and base. Conjugate acid phase base pairs differs only by proton. Hydrochloric acid, the conjugate base is Cl minus. Water, the conjugate acid is H3O plus. So the only difference is just H plus. And what is the limitations? Boron trifluoride, aluminum chloride does not give proton to the another substance, but it behaves as a acid. So this is not explained by Lowry Bronsted concept. So this is some limitations. Let's move to the evaluate yourself part. Here the questions are ammonium, sulfuric acid, acetic acids are given. You have to write the conjugate acid phase base. So in case of ammonium with water, what will give ammonia and H3O plus. Ammonium gives proton to the water, so it is acid 1. So the base 1 is ammonia, and water gains proton, so it is a base 2, acid 2. So ammonia and ammonium, water and H2O are conjugate acid base pair. Ammonia and ammonium are conjugate acid base pairs, and hydronium ion and water are conjugate acid base pairs. Second one, sulfuric acid reacts with water to give bisulfate ion, hydronium ion. So acid 1, base 2, base 1, acid 2. Sulfuric acid and bisulfate ions are conjugate acid base pairs. Okay, and hydronium ion and water are conjugate acid base pairs. Acetic acid dissolves in water to give acetate ion and hydronium ion. Acid 1, base 2, base 1, acid 2. Acetic acid and acetate ion, water and hydronium ion are conjugate acid base pair. Okay, thank you.